Hello, hello. Hi, Howdy
Hey,
Partner World.
hey there.
Hey, Asif. Hey, Michael. And I'm Gitika, and I'm happy and excited to get back to the show with another partner and really excited to show you what we have in store. Before we kick things off, Michael, why don't you introduce yourself and tell us a little bit about Howdy Partner? What is it
Yeah,
and who you think should watch?
yeah. Hey all, my name is Michael. I'm a partner solution architect here at Amazon Web Services. And Howdy Partner is a great show for us to focus on some of our great partners here at AWS and the wonderful solutions that they have to offer and to present it to you all on the great things that they do. It's definitely developer focused. So if you're a developer, data science, data engineer, who's looking to get some hands-on experience with some of our partner products, definitely stick around.
Awesome. Thank you so much, Michael. And I'm Gitika. I'm also a partner solutions architect with AWS. Specifically, I work with analytics partner. And today we have Asif with us, who is going to be actually showing an analytics solutions as well. Asif, why don't you go ahead and introduce yourself and what exactly you would be showing us?
Hey, Asif Kazi. I work for Ahana. I lead the solutions engineering team. I work with customers again to adopt Ahana as an analytic solutions of choice. And we'll talk about what Ahana is as we move along in this presentation.
Awesome. Thank you so much, Asif. So just to give a quick intro, today's episode is mostly going to be primarily for data engineers who work with large data set and looking for solutions to query the data residing in S3 buckets. You can also follow along with Asif today, who is going to provide us with an amazing demo. You can actually also going to be getting a 14-day trial of the product, which you can take free of cost. I'll post the link in some time. But before we get into Ahana's product itself, I want to set up a stage a little bit and give you a quick introduction about Glue, which is going to be working in conjunction with Ahana's own product. So if you're not familiar with Glue and what exactly it is a fully managed ETL service that makes it very simple and cost effective to categorize your data, clean it, enrich it, and move it reliably between various data stores and data streams. It also consists of a feature called as a Glue Catalog, which is a central metadata repository. We have an ETL engine with Glue that automatically generates Python or Scala code, and a flexible scheduler is also present. Glue is serverless, so there is no infrastructure to set it up or even manage it. AWS handles most of the infrastructure for Glue. One thing that I want to go in detail is about the Glue data catalog, which is one of the things which we will be seeing today. Um, it is it contains references to data that is used as source or maybe targets of your ETL jobs within Glue. So how do you exactly create Glue catalog might be one of the questions. So if you want to create it, you can use a Glue crawler. It is a component of Glue service in itself, in which um, crawler will go into, say, your S3 bucket, go through it and identify what kind of data resides in there, what kind of file format is there. And that's one way of creating the metadata. Another way is to create it through a DDL statement in Athena. Athena is a service which is a managed Presto service that AWS offers. A third way of going about it is doing it manually. So you have an option of doing a click and add buttons. Like you can literally go in into Glue service. You can create a new database. You can create a new table, specify what kind of data format is going to be there, where exactly it's going to be residing, and what exactly are going to be the column names. So why do we need a Glue catalog? So having a defined metadata allows you to access your data more easily, as I said, for an ETL job. It can also act as a Hive metastore for another service we have, which is called an Elastic MapReduce. This is beneficial overall because Glue provides a persistent metastore or a metastore shared by different clusters, services, applications, or accounts. That's a little bit of a brief introduction about Glue and Glue Catalog. For those of you who are just joining us, today we are talking about Ahana Cloud for Presto, and we are about to dive deep into a demo from our friend Asif at Ahana. So that is it from my end, Asif. The stage is all yours. Why don't you go ahead and provide us more details about Ahana and the offering that you have for us today?
Excellent. So, great summary, Gitika, about essentially what Glue is, right? And again, as far as customers or users of Presto and Ahana are concerned, that's a perfect way where Glue can be used as a meta store to essentially define external tables on the underlying data set. And again, Gitika pointed out a number of ways through which those tables can be created, right? You can manually create them. You can use glue crawlers, especially this is great for customers who are already in the AWS ecosystem, who are already using Glue as an ETL tool. The third way, which we can demonstrate, and some of that can be seen on the HANA side, is because Glue is a Hive compatible metastore, you can essentially use the either Presto or any other tool which can interact with a Hive compatible metastore to create those tables, right? And again, you'll see some of that in the labs today. Okay. So before we jump into essentially what Ahana is, right? What I'd love to talk about the open data lake architecture and where the ecosystem is heading, right? So I'm just going to go about sharing my screen for a second.
For sure.
There you go. Do you see my screen? Awesome. Okay. So today, as Gitika and Michael mentioned, we'll be talking about SQL on your AWS S3 data lake. But before we jump over there, let's talk about essentially open data lake analytics. So what I'm going to do is compare and contrast the current ecosystem today, or essentially what has traditionally existed, whereas where the industry has been heading for the past couple of years. Traditional ecosystem as far as data lake analytics constitutes traditional data warehouses, right? Today, there are a large number of even on-prem as well as cloud data warehouses, Snowflake being one of them, right? Redshift being one of them, so on and so forth. And that's essentially traditionally what service data analytic needs, right? This is something that end users are intimately familiar with. They're familiar with the relational paradigm or the table structure, and essentially they have data which coexists along with compute and the table structures which you're familiar with, and you can run query on that data set and you can perform dashboarding and analytics on it. It's proved itself tremendously valuable. It's existed for an extended period of time, right? Oracle, Snowflake, Greenplum, so on and so forth, Redshift as well, have been key players in that ecosystem. But one of the cons of that ecosystem is that it's primarily closed source, right? This is essentially proprietary technology, with an exception of a few such as Greenplum, which essentially provide you the performance and the analytics that you need for it. Secondly, in most cases, and again, I'll quantifying that as in most cases, the storage and compute reside together. And that's essentially the architecture of MPP databases, right? This is essentially co-location of storage and compute so that you get the performance that you need. Which means that as the data set grows, right, you're scaling out compute nodes, you're scaling out storage along with it. If you look at it in the traditional sense of an on-prem ecosystem, you're probably talking about expensive EMC or other hardware which needs to go with that compute. But eventually, as your data set goes, it becomes cost prohibitive. With the advent of the cloud and the beauty of S3, what has essentially happened is that now cloud data warehouses have the ability to coexist with Amazon S3, which is essentially you can still land data on Amazon S3 and then pull that data into your cloud data warehouse and perform analytics over it, right? So it gives you the best of both worlds, wherein S3 can serve as a landing zone, and then you have the ability to pull that data into the cloud data warehouse and be able to process it with speed, because of the fact that S3 in essence, is more or less a regional local service to the cloud data warehouse. And you have the ability to pull in the data, right? Even create external tables, so on and so forth. And that way, the cloud data warehouses have moved into the newer generation. But again, for pure performance, you still need to ingest and maintain some of this data locally in the native formats. And as the data grows from like single digit terabytes to tens of terabytes to hundreds of terabytes and petabytes, this quickly becomes cost prohibitive from a total cost of ownership standpoint, right? That's essentially where open data lake analytics comes into play. Amazon S3 has essentially made this available, and essentially technologies like Spark, primarily championed by Databricks, has essentially made this ecosystem what it is today, right? So essentially, what occurs is that you have the ability to essentially spin up separate compute, and Spark is available as a technology, Presto is available as a technology, and essentially now over here you see the isolation of the storage and the compute layers, right? The beauty of Amazon S3 is storage is incredibly cheap, right? Especially if you're not using some of the older data, you have the ability to move it to Glacier, move it to Glacier Deep Archive, and you have a cost-effective solution for analytics, and you're only paying for the data that you need, and you can spin up compute on demand, and that is what makes the radical difference in a total cost of ownership, right? My compute is only there when I need it. My compute is for the
Yes.
size and scale that I needed at that particular period of time. And that's what has radically changed the conversation in terms of both total cost of ownership as well as performance. And this is what a cloud provider like AWS makes possible, is on-demand provisioning of resources. I need 20 nodes in an hour. I have the ability to click a button, scale that out, and get the performance that I need. At the end of the day, I don't need those resources. I can scale it back to the 3 nodes that handles my business as usual queries. Reporting and dashboarding, data science use cases, as well as in data lake transformations can be handled by open data lake technologies. Today, essentially, the leaders out there are primarily Presto and Spark. Right? Any questions, Gitika, Michael? Anything to add over there?
No, I think this is a great overview and great base for where exactly we are going next.
Excellent.
Thanks so
And
much.
and here's the key thing that differentiates Presto as a technology, right? It is completely 100% open source, right? Which means that there is no vendor lock-in, right? Today, you're running it on-prem, you want to move it to the cloud, you could do that. You want to move it from AWS to Google, you could do that, so on and so forth. So it's completely cloud agnostic and platform agnostic. You're not hosted to any proprietary solutions, so on and so forth, right? So that's the beauty of open source, and that's the beauty of Presto. Okay. What I'd like to talk about next is talk about what Presto is, right? And most of the data engineers would have encountered Presto in some shape and form. Gitika alluded to this earlier, right? The most common thing, the most common manifestation of Presto, without folks actually knowing about it, is AWS Athena. AWS Athena
Athena,
is
correct.
completely based on Presto. Yes, Amazon has tweaked it for a fully serverless model, right, to cater to the services and the size and scale that it needs. But yeah, but essentially, Athena is a Presto service. And what is Presto? Presto is essentially an MPP SQL query engine. And again, it has historically been called a Presto DB, but nothing could be further from the truth. It's not really a database in the traditional sense of the word. It's literally a distributed MPP SQL query engine. There are three things that this thing that I'd like to call out as far as Presto is concerned. First and foremost, you can query data in place. That means you don't really have to move data around. Once you've landed the data in S3, you can literally query the data in from there. If you've got other sources, you can use the connectors that Presto provides to essentially query the data directly from the source. And not just that, you can perform joins across those data sources. So you can join data between MySQL as well as S3. You can join data between Redshift, MySQL, and S3. All of those are possibilities, right? As long as there's a connector available, the possibilities are endless. Last but not least is ANSI SQL compliance, right? Unlike certain technologies like essentially Spark SQL, etc., where there might be variation in the lingo, right? Presto is essentially ANSI SQL compliant, which means that you don't have to be savvy with Python. You don't have to be savvy with Spark to essentially run those queries. If you've written a SQL query which essentially says select star from table, you can do that with Presto and leverage the power of Presto with ease. Again, a brief history of Presto, for those of you not familiar with this, is Presto was originally invented at Facebook as a replacement to Hive as a technology, right? Hive, primarily designed to be a batch analytics technology, was simply not cutting it for the size and scale and the interactive query needs that Facebook had. And they went and wrote Presto from the ground up. But keeping into consideration, hey, there are other ecosystem technologies that need to consistently work with Presto so that they don't really have to make a radical jump to get to Presto. And one of the choices that they made, wisely so, was using Hive as a meta store, right? And that's why you'll see Hive is an essential part of that ecosystem to be able to define the table schemas and to essentially gather statistics around the tables. And then the metastore is used to essentially query those underlying data sources, right, based on the table and the schema definitions. I already spoke about SQL or anything, right? There's a federated pluggable connector architecture, so you can literally federate queries across all of those data sources that are mentioned over there in the diagram. And additionally, if there's a data source that doesn't exist, then you can write one. There are over 26 connectors open source today, right? Which community users, companies are essentially using in production. And again, if there's one that doesn't meet your needs, you can obviously write one, either using the Java SDK or using a Thrift interface. Both of those are options. Again, to reiterate, Presto is a completely open source piece of technology. The source code is available out there, available for you to raise pull requests against, right, to contribute to, so on and so forth. The next thing that I want to articulate is the architecture. And if you see the blue box in the center, that's essentially what Presto is comprised about. Right? And we spoke about the distributed multiprocessing architecture, right? So essentially, there's a coordinator node which essentially coordinates the work across workers, and you have the ability to scale out and scale in those workers depending upon your workload needs. Uh, we've gone to the extent to essentially implementing auto scaling on Presto, which means depending upon your aggregate CPU utilization of the cluster, you can automatically add nodes. And similarly, when the cluster is not being used, the cluster will automatically shrink down, go to a minimum set of nodes that you've defined. At the top level is something that's important and near and dear to me, right? We're completely agnostic to essentially what you use as the querying interface for Presto, right? Presto is available to you with an endpoint as a distributed MPP SQL query engine, right? You can query it via JDBC, you can query it via ODBC, you can query it via the Presto's REST endpoint, right? You can use any of the best of breed tools that are out there to make those queries, right? If you're used to Jupyter and Zeppelin and you're a data scientist and you'd like to stick to your pandas and other code, by all means, go use that. If you're more of a BI person, right, you want to stick to Tableau, Looker, so on and so forth, go on and use that. If you're a MicroStrategy person, go on and use that. We bundle Superset packaged into the Ahana solution. And so if you don't have a preference and you're using it primarily from a data discovery standpoint, Superset is available as a tool as a part of the Ahana platform as well. Any questions? Oh. Okay, excellent. Moving on. Again, there are so many logos out there which I can't even fit on this slide deck, right? I just made a feeble attempt to put things out there, right? And one of the first things that I would call out is Amazon, and thank you for having us, right? Amazon is a Presto user for two important reasons, right? Amazon EMR, right, supports obviously Presto as a deployed service. Number two is Athena is available for all of AWS customers to use, and that's again a Presto service. Again, if you see a lot of the Amazon documentation with regards to logs, log management, right? Even the cost and usage report, right? One of the things that you'll see, hey, go dump this data into S3, go use Athena. This is the way you can analyze the cost and usage report. Guess what you're using out there? Presto, right? Again, at the center of this is Facebook, which essentially contributed the project to Linux Foundation. And in the true open source sense, a lot of companies like Alibaba, Twitter, Uber, etc., have made significant contributions to the open source project, and that's what has made the project where it is today, right? And essentially, Ahana is one of the folks that has picked up the baton to essentially run with it. And we are the second largest contributor now to the Presto project after Facebook. Okay,
That's amazing.
awesome. So let's just talk about the Ahana cloud, right? So again, why is there a need for Ahana cloud, right? AWS EMR exists. You can do a do-it-yourself Presto. You also have Amazon Athena, right? The devil is in the
Right.
detail, right? And essentially, that's the value of a managed service. So the way I look at Ahana Presto is that it sits between Athena and AWS EMR. And let me explain why, right? As far as AWS EMR is concerned, right, it's a great service. You can run a lot of technologies on that from the Hadoop ecosystem. You can also run Presto as a service. But when you're running that, the onus of that cluster management, resource and personnel to manage that cluster, tuning the backend configuration, managing availability, right, so on and so forth, falls onto your essentially data engineering or the infrastructure team, right? On the other hand, Athena provides you the simplicity and ease of use, but there's a price to pay for that. Is with that simplicity and ease of use comes a black box, which allows AWS to manage those clusters efficiently because it's fully serverless. You do not have the ability to see, hey, what nodes are being used, right? What's the size and scale of those clusters, right? What is the cluster doing at this point in time? That visibility is not available. And both of these both of these technologies have their place, and that's where Ahana comes right in the middle. Ahana allows you to essentially deploy a cluster with resources of your choice, right? uh, Keep it running when you need, shut it down when you need, scale it out to what you need it to be, and without any operational overhead, right? You do not need a dedicated data engineering or infrastructure team to sit and manage those clusters. We automatically manage it for you. We intelligently tune the backend defaults depending upon your cluster size, your workload requirements, so on and so forth. Above everything else, right, we provide point and click interface to connect data sources, right? You don't have to worry about, hey, what do these configurations need to look like? How do I tweak my glue connector? How do I tweak my Hive connector? We manage that automatically depending upon what you select as your workload profile and what you select as your instance type, and we'll have the ability to show some of that to you, right? And again, if you see the diagram, it's broken down into two parts, and it's important to talk about that. The first part of it is the Ahana SaaS console, which essentially sits within the Ahana VPC. The second piece of it,
Mm-hmm.
which is the larger piece of it, which you see on the right, is essentially something that entirely sits in your environment. Ahana, in no shape or form, has any access to any of your data, right? The only thing that gets exchanged between the Ahana SaaS console and the in VPC compute plane in the customer's VPC is control messages, right? So all that Ahana sees is, are your instances up or down? And depending upon your user interactions with the console, it can say, hey, you want to scale up the cluster? Hey, compute plane, can you scale up the cluster for the user? Or you want to scale down the cluster? You can do that. Or if you make a request to add additional clusters, the Ahana SaaS console can essentially send the request to your VPC compute plane, right? So it is a fully secure environment, and unless there is a network part to get to the data cannot be accessed even from within the compute plane itself, right? So you need to explicitly set up a peering connection to your MySQL, to your RDS, to your Redshift if you need the cluster to have access to it. The access is not enabled by default. Okay.
Okay.
So where's the fun without seeing all of this in action, right? So why don't we just jump into and look at first a high level demo, and then we can jump into some labs after that so that you guys can get some hands on. So give me a second while I set this up.
For sure. And Asif, can you tell everyone if they want to utilize this service or if they want to test it out, how exactly they can go about doing that?
Awesome. So Ahana offers a 14-day free trial, and that trial could be guided or unguided. There is no cost to you for the 14 days of you utilizing the service. If you do need some hand holding, then my team does work closely with you to onboard you, right, for the trial, to help you. To importantly, the first thing is understand the use case, right? Discuss whether it's a good fit or not, and discuss how you should go about executing the trial so that you get the desired outcomes that you're looking for, right? That's route number one, which we call as a guided trial. Route number two, you're tech savvy, you know Presto in and out, you know AWS in and out, you don't need our help. Just go there, sign in, click of a button, compute your set up your compute plane, go play around with it. And then if you like it, continue to continue to use our product or service. Would love to hear the feedback that you have, and would love to work with you if you need additional guidance on the use of the technology or the best practices. And that's what our team is here for.
Amazing. Thank you. Let me know once you're ready with the demo.
Sure. Give me 1 second.
While Asif is pulling up, Michael, why don't you just tell us what we are doing, what exactly is Asif presenting to us, just a quick summary. So for those of us, for those of the people who are joining us new.
Yeah, if you're just joining us and you haven't been here for the last 15, 20 minutes, we've been talking to Asif from Ahana, and we're going to walk through some demonstrations on how to set up your Presto clusters with Ahana, and how you can query data on AWS or query your data that's sitting on AWS, and all the other fun things and fun benefits that Ahana provides and manages for you. Yeah.
Awesome.
Awesome.
Cool.
Thanks so much, Michael.
Okay. I'm ready to share whenever you're ready to go. Okay. So here's what happens. So fast forward a little bit. You've gone and provisioned your compute plane within your VPC. This is essentially what you're going to be presented with, right? Again, as I mentioned, the promise of 0 to Presto in 30 minutes, right? You can essentially go and create a new cluster. You can specify a name. You can select the instance types that you need, right? In this case, I'm going to leave it to defaults. I can either choose a static scaling policy. I can choose to automatically scale out and scale in depending upon the CPU utilization. I can select the default or the minimum number of workers that I want out there. And optionally, I can scale to a single worker when idle. And let's talk about this piece of feature functionality. Here's what happens, right? You have a cluster, you'll say that, hey, for my business as usual requirements, I want to run with a minimum set of, say, 5 nodes or 10 nodes. But guess what's happening overnight? Nobody's even using the cluster, right? So you at least need the ability from a cost saving standpoint to have at least one node which is going to take the initial query. It might not be as performant on the first query, but at least it's taken the initial query. And then once the query hits, you can scale back to the business as usual size. Or again, if your workload increases, you can scale out based on CPU scaling. And this is essentially what scale to single worker on idle does is, hey, if for 30 minutes nobody's using the cluster, right, it essentially takes it down to a single worker node, leaving the coordinator there to be able to take the query, right? Next thing is we spoke about Ahana Hive. We spoke about the Hive metastore, right? Glue
Right.
is a Hive compatible serverless metastore. If you're a big user of Glue and the AWS ecosystem today, we obviously recommend using Glue as a technology so that it ties into your ETL workflow, so on and so forth, and you don't have to go back and recreate the tables. There are other instances where either customers are using their own managed metastore, or they're using EMR and they're using Hive on that, or alternatively, they don't have one. If they don't have a Hive metastore, we have the ability to provide a managed metastore, and this is all that that checkbox does. You can choose to enable it or not, right? Entirely up to you. If you're not using it, you can turn it off. Additionally, we provide something which EMR as well as Athena don't provide today, is essentially IO caching. What this allows you to do is essentially cache fragments of data from S3 right into a local cache so that you're not hitting S3 over and over again, right? We've seen about 3 to 15 times performance improvement depending upon the concurrency and the workload that the end user is using. Next thing what you do is select one of the users that you have, or you could create a new user, and then all you have to do is create a cluster. Done, and that's all it takes to create a cluster. You're not going there modifying the 50 configuration files that are there. You're not doing the calculation. Okay, what is 70% of my memory amount to how much of headroom do I need to this thing? Depending upon what you selected from an instance type, And depending upon the concurrency workload, whether you selected high concurrency or low concurrency, all of those configurations are automatically configured and managed for you in the back end. And all you have to do is fill a form, right? It's like going and filling a survey form, select OK, and there your cluster is in the process of creation. This will be done in 15 or 20 minutes, and you're ready to go. Why don't I show you some other pieces of feature functionality? We'll also do some of this in the lab, but I'm going to quickly walk you through some of this. Right? The second piece of functionality is data sources. Again, remember, as far as data sources are concerned, they essentially allow Presto to be able to connect to those sources. And in the Presto world, they're called as catalogs, right? So what I'm doing over here is configuring catalogs to be able to go and connect to endpoints, which you can use to query via Presto. So let me just show you an example of my glue catalog. All that I've configured here is my glue. I've specified the region. I've created a role, and that role is essentially used to go and gives me the requisite access to my glue to be able to go and query the data from there. Right? I can also go and configure data sources from scratch. There are the most common set of data sources which end users use available on the UI. There are about 26 odd data sources that are additionally available, and those can be configured and attached to the Ahana clusters as well. And they simply work seamlessly, and you have the ability to literally federate queries between any of those data sources. So I can query data between Glue and Redshift, right? MySQL, RDS, and Redshift, right? Elasticsearch and Redshift. The possibilities are just endless as far as the ecosystem is concerned. I'd mentioned this earlier. There are two primary ways in which connectors work, right? You can either write a connector from scratch using the service provider interface, which essentially Presto has defined and exposed, or alternatively, you can use set up a service which is based on Thrift, and you can use that as well, depending upon how you set it up. And the end access, you need to provide either an IAM role or an access key to be able to access those services. Okay. Once you've defined a data source, all you have to do is literally go to your cluster, click manage, and essentially say manage data sources. And then you can say, hey, I want to attach these data sources to my cluster. And then you can say modify cluster. And once you do that, it'll prompt you to essentially restart the cluster because it's going to go and configure all the worker nodes and the coordinator with that information. And then once the cluster is restarted, it's fairly quick. You're up and running and have accessibility to those data sources. Okay. Now that we've spoken about data sources, let's just show you a quick example of federated querying. And
Asif,
yep,
I do have a quick little question. So we went through that screen, and you had a list of 6 data sources, and you touched on a little, and I just want to make sure that we can drive it home. There's definitely other data. Are there other data sources that we can pull data from? Maybe I'm not using those exact ones. Can we pull it into Ahana as well?
That's correct. So there are 26 odd overall data sources that are available, right? Our team can help you manage and configure, right? The simplest and easiest ones for end users are exposed in the UI, right? We add additional tiles as customers request. From a simplicity standpoint, we expose only the most common ones, but you can at any time, because you've got access to the cluster, configure any additional data source, right? Pino being one of the most common ones that is configured, right? So that would be a good example. Oracle would be another example, right? Microsoft SQL Server is another example. Depending upon your use case, you can configure any of the other available data sources with the Ahana cluster.
Perfect. So just like if I'm using Presto on my own and managing myself, I can just walk right in with Ahana and start taking advantage of stuff like that. Is that correct?
Absolutely. Yep.
Awesome.
It's your cluster. You've got full access to it, right? And we help customers in terms of, okay, here's how you go about it. It's all obviously documented in our documentation as well. And we're happy to provide guidance on how to go about doing that.
Awesome. Thank you, Asif.
Okay. So the next thing that I wanted to show you guys is a quick and simple example. Again, this is in the labs as well. What I'm doing here is demonstrating federated query. I have a small MySQL database which has information about my movies. I have data as far as the same movies. Their ratings are stored on S3, but essentially glue is my meta store, and it defines essentially the definition of those ORC files sitting on S3. And what I'm doing over here is literally running a query, and we're just joining the data of about 6,500 rows sitting in the MySQL database against 25 million rows sitting on Amazon S3, and I'm just running the query against that database. The thing that you'll see over here, there are a couple of things that are going on over here. There's obviously grouping going on over here. Additionally, I'm performing aggregations, right? Rounding,
Mhm.
counting, as well as ranking across over the data set. As you'll see over here, that query took an order of 18 seconds or so, right? 25 million records joined against about 6,500 rows on a teeny tiny MySQL instance, right? Came back in an order of 18 seconds. And that's the beauty of Presto. Presto is linearly scalable, which means that as you add additional nodes, as long as your query can be broken up into individual parts, you have the ability to linearly scale the performance with the number of nodes that you add. And again, the underlying technologies behind that make that possible. Obviously, the segregation of storage and compute being one. Secondly, is the resiliency of S3 as a data lake source, right, makes that possible. Okay. Questions on this? Okay.
No, this is amazing.
Okay, last and but not least, this is what end users care about. Hey, I have this cluster. I don't need it for the rest of the day. What do I need to do about it? Right? You can stop the cluster, restart the cluster, or delete the cluster if you're not planning to use it. I already demonstrated the scale to single worker when idle. So if nothing's going on, you're okay with essentially incurring a minimum charge for a single node so that no query fails. If somebody in the middle of the night decides to run a Presto query, right, that is an option. You can do this via the user interface. Additionally, we do provide API keys as well, right? So you have the ability to create a
Mhm.
new API key. There is a comprehensive API available to essentially discover your clusters, manage the cluster, start, stop, restart, so on and so forth. And that, if you don't want to be dealing with the UI, right, and you want to do that all through code, all of those are options as well. Okay. That's a good 360-degree overview. Let me essentially show you the stuff that when I talk to customers, they miss on when they're working with Presto on Athena, right? And that is essentially access to the Presto query interface. Let me just show you that. Did I spell it right? No.
So,
Did I?
Asif, I
Hmm?
had one question.
Sure.
In terms of like target as to where exactly the data can be utilized, the data which is retrieved, is there any integration available with data visualization tools?
Okay. Yes. So as we said that as far as Ahana is concerned, it's just the SQL query engine, right? So
Right.
essentially, if you see when you go over here to data sources, right, you can see the backend connected data sources. But when you go to the connection details, right, there are two things that you'll see, right? First and foremost is the REST endpoint, right? And second thing
Mm-hmm.
is the JDBC endpoint. So if you're
Mm-hmm.
using Looker or you're using QuickSight or you're using Tableau, all of those can use a JDBC or ODBC connection, right? The traditional way that you're used to querying and visualizing data, you can use it. For as far as those tools are concerned, they're none the wiser. All that you need is the appropriate driver and the endpoint, and you can get up and running as you quickly, right? So doesn't matter if you're
Got it.
visualizing via Excel, doesn't matter whether you're visualizing using Tableau or Looker, right? You can do that using the Ahana cluster. Okay.
Thank you.
So this is what I wanted to show you. Right, I have a query running. I'm assuming, yeah. So here you can see the query running. I can actually dig into the details of exactly what's going on with the query, right? What are my workers doing, right? How is the task split, right? What are the resources, right? So on and so forth. All those details which you don't have the ability to get on the Athena side, especially when you're
Mm-hmm.
running workloads which are essentially sub-millisecond, and you really want to know what the query is doing, what is the plan like, what's going on, right? Ahana has the ability to provide that to you. Right? So that's a quick high-level demo as far as Ahana for Presto is concerned. What we could dive in next is the labs. And again, Gitika, if you want to share the labs guide, that'll be great. I can walk the team through it as we move along. Okay.
Yes. Share the lab. Oh, thanks, Michael.
1 second. I'm gonna move a few windows around so that everybody can see it. Okay. So here's what we're going to do. You guys would have the PDF version of the doc. I'm just going to use my Google Docs version. It just makes it easier for me to copy and paste. I can zoom it up a bit so that folks can see it. Probably better and not worse. Give me a second. Okay, is that better? Okay. So the couple of things, right? First and foremost, again, this is a demo environment. I do not want everybody to go through setting up the compute plane today. So you're essentially seeing an environment where the compute plane is pre-provisioned, right? When you sign up for Ahana, you'd need to go through an initial set of steps to set up your compute plane. But once the compute plane is set up, you have the ability to simply log in and perform the steps that we're going to do. Here's the email address and here's the associated password. Again, for those of you who you want to follow along, please use these credentials to get into the clusters. If there are any questions, just feel free to ping those over on the chat, and then we can address those accordingly. And we can quickly get going. So I'm already logged into the cluster, so I'm not going to bother logging in. But essentially, what you need to do is sign in, and once you sign in, you would be taken to this screen. Once you're taken to the screen, I would simply click clusters, and clusters would give you an understanding of all the clusters that are running. My request to the audience, for those of you guys are following along, there is a C1 through C7 set of clusters randomly, and I repeat, randomly pick one cluster. Randomly is not pick the first cluster, right? So just arbitrarily pick a cluster so that we divide the folks who are on the live stream are distributed across those clusters. Okay, and once you're logged in, then we can dive right into essentially connecting to Ahana via Superset. And again, I'll show you how to get to the UI, but I'll wait for a bit and see if folks have the ability to get in. Right? Any?
So, Asif,
Mhm,
I had one thing.
mhm.
For those people who'll be watching this on demand, by when can they actually have access to this cluster? So, say someone wants to come in, test this out at a later point.
Mhm.
What would be the deadline look like for these
Right.
clusters?
So typically when we do labs, we make it available for the next 2 or 3 days, right?
Okay.
Again, understand and appreciate this is a Thanksgiving weekend, right? If you reach out to us directly and you want to tinker it around with it for a day, happy to do that. Honestly, my personal experience working with customers and the community has been nothing better than working with your own data, right? So the fastest way to get going is
Yeah.
essentially, hey, go sign up for a trial, 14 days, it's free, and sign up, work with your own data. If you need a guided trial, we can help you through that. If you want to do self-service, you can do that as well. Okay,
Got it. Thank you.
cool. So the next thing after that is we want you to sign into Superset. The way you go about signing into Superset is go to the randomly selected cluster. I'm going to randomly go select C5, go to Superset, and then just click this square with that arrow. And then once you click that, it is going to bring up a pop-up. It'll ask you for the credentials. Since I'm already signed in, my cookies are there, it's signing me right in, but it's going to ask you for the credentials. The credentials you will find in the document. and they're right here. It's the same credentials that you use to log into the Ahana console, right? Just enter those credentials and you should be able to sign in. Okay. So I'm going to wait, pause for a second or so, see if folks are following along. Assuming you were able to get in, the next thing that we want to do is open up a query interface. The way you go about that is go to SQL Lab, click SQL Editor, and it will open up a query interface for you. Mine was already open, but for example, you just got here. Here is a new tab. This is what it's going to show you. Next thing, what you want to do is, again, because superset is a shared instance across all the clusters, the same thing that you did, select the same random instance that you chose to use, select that appropriate connection. I'm going to stick to C1 for my demo and make sure that that connection is selected on the left hand side. And then we could go about now getting our hands dirty with Presto. Again, this demo is not meant to be uh, in any shape or form deeply technically geeky, right? Anybody from business analysts to folks who have never done this before can follow through, right? If you do want to go and attend the geeky demos, sign up for our newsletter, right? Every month we do a deep dive, one-on-one, 101, 102, so on and so forth. So if you're interested in getting into the geeky demos, A, sign up for the newsletter. B, you can find us on the community, Presto community Slack as well. We're all there, right? Ready and available to answer questions that you might have, right? So I spoke about this earlier, and let me explain the concept of a catalog, right? A catalog is essentially a manifestation of the connection to the end data source. A catalog is essentially what you define with properties saying, hey, this is the endpoint, here are the credentials, here's how I want the catalog to operate. The various catalogs that we predefine with the Ahana implementation, so that hey, you have some data to just start querying. One of them is TPCDS, the other is TPCH, right? These are essentially well-known industry data sets which you can use to essentially do performance testing, benchmarking, and so forth. In this example, we're simply going to go and look at what catalogs have been connected to my cluster. Right? So I go there, I go say show catalogs, I go run the query, and Ahana, right, will kick off the query or using Presto, and it shows all the catalogs that are connected to my cluster itself. Again, you're seeing this list. Your production clusters or your test clusters will look significantly different depending upon what you've configured. In my case, when I created the cluster, I did select, hey, I want a HANA Hive as a meta store. So I do see that. There's a system catalog which allows me to get systemic information. What are my queries doing, right? What are the statistics that are associated with the queries? Who ran those queries, so on and so forth. So that information is available. I have a JMX catalog which can give me information about the memory usage, the cache usage, so on and so forth, right? And the TPCDS and TPCH are primarily sample test data for you to use for essentially just benchmarking or doing some basic testing. And we're going to be using some of that for the demo. And MySQL is essentially what I have attached to this cluster. You saw in the demo earlier how I ran the join between the ratings table in MySQL, the ratings table in S3 against the movies themselves, which are residing in the MySQL database. Okay. Next thing, if you're following along, let's talk about the concept of schemas, right? Schemas is typical in any database. It's essentially a segregation of a set of tables. Over here, I'm going to see, hey, show me the set of schemas that reside within TPCDS. And you will see that over here in terms of what TPCDS provides. Similarly, if I were to do the same thing for MySQL, you would be able to see what schemas exist on the MySQL side. There you go, right? There are a number of sample databases over there. There's a performance schema, the world famous NYC taxi schema, airlines and flight information is also available, and a sample database, right? So this essentially gives you, hey, now what are the schemas and what can I query, right, for my connected data sources or catalogs. Next thing, what I'm going to do again,
Asif,
yeah, go ahead.
one second. Can you make the text a little bit bigger?
Oh, I keep forgetting. Okay, let me do that. Yes.
Yeah. Yes, I think that should be
Oh,
good.
okay, too big. There you go. Better?
Yes, much
Sorry
better.
about that.
Thank you.
Yeah. Okay. So now that we've seen schema, what do schemas have? Schemas have tables, right? So why don't we look at the tables that are available in one of the schemas in TPCDS, right? So now it gives me the list of tables that are there in the schema. Again, you'll note over here, I'm following the level dot notation for indirection, right? I started off with this.
Hmm.
I start off with a catalog, right? I said show catalogs. Then I said show the schemas from that catalog, and now I have access to the tables, right? So now I can use the dot notation to directly reference one or more tables that I want to query. And that's essentially what I'm going to do next. Let me zoom this up a bit as well. I am going to essentially go from the SF10 schema. I'm going to query the customer address table, and I'm going to limit my query to only 10 rows, right? There are many more rows in there, but just for the sake of demonstration, I'm going to go and select 10 rows from the table. And there you see it, right? You can exactly see what fields
Hmm.
exist, right? What is the data? And you've been able to see a uh, sample of that data that exists in that table. And you can follow the same approach to go and look at other schemas, other tables, whatever interests you. Okay. Now we come to the fun part of the exercise, right? And that's why all of us are here, is essentially going and pulling data from S3, right?
Hmm.
Again, I'll pause here and talk about this a bit, right? Because generally when we conduct the slabs, many folks end up using it. If I set the example to go create table with this table name, everybody's going to use the same table name. My recommendation would be put a random number in front of it, or put your initials over there, or use some sort of initials. Otherwise, you're going to say the table overview already exists. That's not something that you want. So make sure that, hey, you substitute this value with either a random number, a lucky number of your choice, or your initials. Either one of those works, right? So let's go and do this. Okay. Uh, okay, I might have messed something up, but anyway, let's go here. Okay. So what I'm going to do over here is I'm going to create this table, right?
Hmm.
Uh, and AK is already used. I'm going to try AK-47, and let's see how far we can take this, right? And go run this, and it went and created the table. Next thing what we want to do is query the data, and I know why this might not work, but let's go and query it, and I'll explain. And this is a good learning exercise, right? I went and created the table AK-47, and I'm going to go run it. And it returned the data, but essentially there's a couple of things that you see over here. Is that, hey, I should have skipped the first row. I didn't, right? And that's why this thing showed up in the set of records. Obviously, as a part of that create table, there are additional properties which you can provide, which will say, hey, skip header row, and that way this data set is not going to show up, right? So let me take a step aside, and we will jump into the fun conversation we had, is why is a meta store important? And I will go back to the query that we had. Okay, so here's the create table statement. I'm going to format it a bit so everybody can read it. Okay, so what am I doing here, right? There's a CSV for movie ratings. It sits on S3. Uh, but I need to query it, right? But guess what S3 is? S3 is a pure play object store, right? Presto is not going to intelligently figure out, hey, there is a CSV over there. How do you want me to interpret those fields? It could be a CSV, it could be a TSV, it could be any field separate, right? That's one example. Other than
Right.
that, There could be binary formats, right? There could be or Parquet, so on and so forth. So as an end user, you need to be able to go and tell Presto what the schema of that underlying file is, right? What format is it in? And then how do I interpret the fields? And that's essentially where a meta store such as Glue comes into play, right? And over here, remember what Gitika spoke about, there are various ways to go ahead and create a table. One way I could have done this is simply gone to my Glue, right? Created a crawler, pointed it to this location, and said, run this crawler. And Glue would automatically go and create the table, right? Define the fields automatically.
Right.
And then using the user interface, if you needed to tweak some of the data types or if you needed to tweak the field names, you could have done that, right? But essentially, it would have been a completely hands-on exercise, hands-off exercise. I could have said, "Hey, Glue, can you go crawl all of this data, and go and discover all the data that's over there, right?" It's not just about discovering a single table. It could discover any number of tables that are there in the path. As an example, if ratings, movies, right, tags, reviews, all of those were under this demo one folder, once I kick off the crawler, it would have automatically gone and created all those tables and automatically set up the data types, etc., making those tables available for you to query. And that is essentially the power of Glue as a piece of technology which is integrated within the AWS ecosystem. And we can leverage all those benefits, right, to do all, to essentially to leverage all the hard work that Glue has done and simply use the central consolidated serverless metadata catalog that AWS has to now go and query those underlying data sources. Okay, so that's essentially why you need to have a metadata catalog such as Glue, and that is essentially why you need to have some way to define the table definition, right? You can either manually do it, or you can use a metadata, or you can use a crawler such as Glue to do it. Okay. Off my rant. Hopefully that helps understanding why the meta store is important.
Mm-hmm.
And again, you don't have to use Glue. You could use, if you're already managing Hive on EMR, you could use that. If you're managing your Hive independently, you could use that. If you want to use the Ahana managed Hive, you could do that. All of those are options. Okay. Next, let's go back into create table as, right? Again, why is create table as interesting? CSV, JSON formats, or even text formats are interesting because they're readable. But guess what happens when you're using CSV and text formats, right? That they are very expensive in terms of parsing, right? Which means that every time you're querying that data set, right, you're going and parsing the row, right, figuring out the field delimiters, right, extracting those individual fields. And from a pure play query standpoint, this turns out to be expensive. CSV and text are less expensive, right? But the moment you're talking about JSON, you're talking about an in-memory representation of every single row that the query engine is going to pass through, and that is essentially makes your query slow and essentially memory and computationally intensive. And that's where binary formats such as Parquet, ORC, Avro, and others come into play. And again, the beauty of Presto is that it supports a wide variety of those formats. In this example, right, you can convert your underlying CSV data into any of the numerous formats over here. I would recommend just convert it into Parquet or ORC, and let's just quickly do that. And again, I'm limiting this to 100,000 rows for the demo. Remember, there are 25 million records over there. I would strongly urge you not to run this for every single format against all of those 25 million rows. The intention over here is simply to show you what this looks like, right? So over here, I'm going to store it as Parquet, and I'm going to continue with the AK-47, and I am going to go and run this query. And I broke something. Let's see what I broke. Mm-hmm. Table, Glue, format, Parquet. Love this when this happens. Why is it saying 2 dots, line 7? Oh, yes, obviously. There you go. AK-47, right. Okay, so don't repeat the mistake I did. Make sure you substitute that value in every place. Voila, right? It's gone and written these rows now in Parquet format, and those are available. So why don't we go and see? We'll go to workspace. Again, I'm just showing you an alternative way to go and query that. And here's my AK-47 ratings Parquet with 100,000 rows. And again, this will take some time to show up. I just wanted to show you a convenient way. And again, all of this is again data setting in Parquet, which is now written back to S3, right? So minimalistic ETL, right? So if you want to take a data in one format, right, create a subset of that data in another format, all of that you can do. Over here, I've just done try casting. Nothing prevents you from using case statements or using additional conditional criteria, which you can use to essentially ETL or transform that data. It's more like ELT more than ETL, but essentially you get the idea. Okay. Again, feel free to go through these samples, right? There are multiple options available over here. There's an interesting lab as we move through this is comparing the performance of different formats, right? And goes back to the conversation I was having earlier. Textual formats are great if you want to continuously be staring at the data and reading those files. But if that's not something that you're doing, we strongly urge to use columnar optimized formats such as awk and parquet. Those are de facto formats in the industry today, right? For two reasons: a, they're columnar compressed, right, which means that not only are they saving you on disk space, but are significantly faster in querying in terms of performance. That's number one. Number two, guess what, right? They have got header footer information, which means as the Presto query engine is scanning through those files on S3, it can simply look at the header and footer and say whether or not this file is interesting and is there any data that I need in here. And if it isn't, it can just inspect the header and footer. If not, skip the file, right? And imagine when you're going over billions and billions of these files, right? Skipping those files, right, could make a monumental difference in the performance that you're going to get, right? So great way to essentially optimize your data lake. Highly recommend using the columnar compressed formats. We spoke about federated querying, but for the sake of completeness, I'm going to go through the movie lens example. Again, similar to what we did earlier, I am going to use the catalog.schema example to go and look at what's going on. And I want to, so there are three tables over there. One is movies, the second is movies metadata, and the third is ratings. All of them have different information. I am not going to be using the ratings table, which is setting in MySQL, but instead I'm going to go and use the table that is setting in S3 instead. Okay. And next, what I'm going to do is go and run this. So for simplicity, let's go here, paste my query. This was AK-47. This was Parquet. And let's go run this. And I broke something. Let's see what I broke. Line 11. I forgot something from the query, which is on the next line. There you go. Sorry about that.
No, it happens to the best of us. Things tend to break when people are watching somehow.
Yes. Learning exercise. It's good for things to break so that I can correct my mistakes and everybody doesn't repeat them, right? So here you go, right? Order of 2 seconds, right? Leverage the columnar optimized format, which I just created to go and query that entire data set, running a federated query between MySQL movies and the newly created Parquet data set, which resides in S3. Okay. You can do the same thing for ORC. And again, one of the things that I'd highly recommend, right? Try creating the table with JSON and try creating the table with ORC. And then run both of the queries, right? Run it with JSON, see what the performance is. Run it with ORC and see what the difference is. And you'll see an order of magnitude difference between those two, right? Might not be evident for 100,000 rows. The moment you're talking about the full 25 million rows, right, you will see the difference, right? And imagine all those customers who are running this on billions and billions of rows, right, with hundreds and thousands of partitions, right? You really want to be storing the data in columnar compressed format. Okay. And here's essentially what I was talking about, right? You could either use that query as an example or simply do a count star, right? The performance would be very, very evident to you. Okay, we're on the last lab at this point in time. I have screamed through the entire live streaming. And again, this I'm going to leave it on if you want to use it, but I'm going to paste it in the private chat. And I just kicked off this instance yesterday. So again, either Michael or Gitika, if you want to make that available to the users, that would be great.
Will
Again,
do.
For sure.
this is just running Jupyter Notebook, right? Again, if you have a running Python environment, you're already familiar with some of this. You can use a local Python, but for convenience, like I said, these labs are meant for anybody to be able to go and run it. Here is just a Jupyter Notebook which you could use. I'm going to open that and show you what it looks like. The password is mentioned in the lab guide, so you should have access to it as soon as this thing shows up on my screen. Ta-da! Okay, and there's an example Python notebook over there. And again, for those of you guys are interested in, hey, I don't care about the graphical user interfaces. I don't want to touch Tableau. I don't want to use Looker. I'm a data science guy. Everything that I do is through Python and Pandas, and that's what I'm going to stick with. And that's fine. If you love Matplotlib and all those libraries, I'm with you, right? Feel free to do all of your analytics and queries through Python or the tool of your choice. If you're using R, there are R libraries available. If you're using Node, Node libraries are available. Obviously, the Java can also leverage libraries that are available over there, right? So again, just for the sake of completeness, depending upon which religion you conform to, right? I've put there Presto, the native Presto client. I've put PyHive, and for those who love and live with SQL Alchemy, there's a SQL Alchemy example as well, right? So feel free to use any one that you see fit, right? The three examples are available for you, right? It's simple, right? Essentially, you set up a connection. You essentially say what catalog you want to use, right? The username and password, and then I'm running a simple query against the system catalog. Again, I could have run it against any other catalog. The intention over here is to show you, hey, what additional metadata can I get out of the cluster, right? I want to know what version of cluster am I really running on, and this is one of the ways to go about it, is use the system catalog, right? You'll know exactly what nodes, what are the node IDs, right? Which is the coordinator, so on and so forth. All of that can be made available, right? So over here, I have that piece of code. I'm going to simply run it, and then I'm going to use my beautiful tabulate API, assuming this thing is going to run. What happened to it? Okay. I don't know how many people got on, but seems to be running slow. But in any case, what you will see is that, hey, you'll see the results of the cluster. And over here, you'll see that, hey, this is the node version. It'll tell you which one is the coordinator. It'll tell you whether the node is active or it's indisposed for whatever reason. All of that information is going to be available to you. Okay. So again, great way to get started with Presto. Again, what we've done in these labs is shown you operational management of the clusters, right? Again, the beauty of Ahana sits right between heavy operational management and extremely simple ease of use with Athena. If you want a mix of both worlds, right? You want to manage your clusters, want to complete visibility into what's going on with the clusters, scale out and scale in depending upon your needs. And not just that, right? Get up to speed with the latest and greatest versions of Presto that are out there. Ahana has the ability to provide that for you. That's number one. Number two is Ahana, as I said, is the number two contributor to open source Presto at this point in time. We're putting in tons and tons of innovation into Ahana at this point in time, right? Some of the things that you don't see traditionally available in Ahana, which is expected to launch first week of December, right? And I'm holding my product management team to it, is Apache Ranger integration, right? So you'll have granular access control over, hey, what columns can end users see, right? What schemas can end users see, right? So completely locking down your Presto environment for security, right? For all the nice things that financial services teams and healthcare teams, everybody cares about, right? So that's going to be something that I'm really looking forward to. Customers have been asking for it. Their wishes will be answered. Early Christmas gift for everybody, right? So looking forward to that being announced, right? Other than that, you'll see a lot of innovation that's going on in the back end. One of the things that I'd love to talk about is essentially rewriting the backend worker engine in C, C++. Yes, it's more of a long run process, but that's something that our team is aggressively working upon. And then that will radically change the performance profile of essentially what Presto offers. So if you think Presto is fast today, wait until the C, C++ worker is available and it's going to be screaming, right? So again, excited to share this demo with the AWS audience, right? Uh, Lots of value that Ahana provides, right? Again, we believe in the better to get a story, right? Glue with AWS, centralized ecosystem in terms of managing all your metadata, all your catalogs in a central place. Query the data using S3, go to the open data lake technology. That's essentially where the world is heading towards, right? So that's all we had for today.
Thank you so much, Asif. I was actually going to ask you what the takeaway is, but I think you covered it so well already. I don't think I'm going to ask you to repeat, but I didn't have any questions. I love that you were able to walk us through how exactly Ahana fits into the picture, what exactly is the significance that we already have EMR and Athena, how Ahana fills that gap in between. So I loved having you over. Michael, did you have any questions, anything to highlight from your end?
Yeah, I just wanted to just make sure that we really highlight, like, this is the Presto that you know and love and you've been using for so long, and you can take advantage of these great benefits that Ahana has, and not all the management, but still the insight into what's going on while still using everything that you've already been using. And I think that's just so awesome. And I just want to make sure that our newcomers, I see we've been jumping up a little bit in viewers, that they know that this is the Presto you know and love. You can do everything that you've been doing without all the effort. It's here for
Awesome.
you.
Excellent. So shameless plug, there is a 14-day free trial, guided or unguided, whatever route you want to take, right, Michael? If you just don't mind just putting it out there for
Yes, yes.
folks to sign up for, right?
Awesome.
You
Awesome.
too can talk to Asif, and he can help you out with this.
Awesome.
Let me drop it in the
Yes.
chat.
And one final thing, so Asif, we have a tradition going on where before we log off from Howdy Partner, we have our guests sign off with one of the three phrases. One is giddy up, happy trails, and see you all next time. So which one do you want to go with today?
So this is a goodbye, but not a goodbye. So see you all next time, right? So that's essentially what it is.
Awesome. What about you, Michael?
I'm game for any of them. It's up to y'all. I'll leave it to you, Gitika.
Awesome. So for me, also see you all next time. And th it was great having you, Asif. Thanks so much, Michael, as well. See you. Bye.
Thanks,
Thanks, y'all.
guys.